Today we have Max here to talk about React, and in the tech talks we always seek topics that we also touch. So we at Newstore develop our consumer-facing apps using React Native and React Web, and we obviously also recruit. So if you wanted to work with React for money, that's your chance. Reach out to everyone wearing such a red badge like I do. And nothing more to say. Max, the stage is yours.
Thank you. I just had a chat with all the engineers from Newstore, and they're actually doing some interesting stuff here, so definitely check them out. And the second thing I want to say before I actually start with my talk is how nice is this auditorium. I mean, you've got all of those, like the wood things back there, you've got a huge screen. This is lovely. Like, I organized the React Vienna Meetup, right? And we're in this sort of shabby co-working space, right? This is freaking amazing. This isn't like a meetup, this is like a conference. Yeah. This is really nice. So, anyhow, my name is Max. If you haven't met me yet, my Twitter handle is @mxstbr, which looks a bit hard, but it's actually just my name without vowels. So if you remember my name, just take out the vowels and you'll have my Twitter handle. I work as an open source developer at Thinkmill. Who in here has heard of Thinkmill? Oh wow, like a dozen people. That's nice. I did not expect that. So Thinkmill, we're an agency based in Australia. I'm not from Australia, right? I'm from Austria. As you hopefully know, that's not the same thing, all right? We're an agency based in Sydney, and we do full stack JavaScript, meaning we do Node.js on the back end and tons and tons of React and React Native on the front end. And my boss is Jed Watson, whom you might know for class names or React Select or KeystoneJS or any of those things. And so we do lots of open source, and I basically solely work on open source. As such, you might know me from some of my projects. The most famous one of which is react-boilerplate, which is a huge React starter kit, which just recently crossed 10,000 stars, which is pretty weird. It feels weird to have a project that has 10,000 stars, right? It's sort of, so many people like it. But anyhow, so the second one is KeystoneJS, which is a Node.js content management system for which we built ElementalUI, which is a React third-party component library that we use in Keystone. And then more recently, I also make styled components, which is a new and the best way to style React apps, all right? So if you haven't seen it yet, rewrite all of your production applications with styled components. I'm just kidding, don't do that. I have stickers for all of those except for styled components because it's so new, the stickers haven't arrived yet. I've ordered them, but they haven't arrived yet. So if you want any stickers, just come find me afterwards and I'll give you some. Today I'm here to talk about testing, right? And the first question I sort of want to ask is, which types of testings are there? Just scream at me, say some, like performance testing, you know? Which types of testing do you know? Unit testing, okay, that's a good one. Sorry? I heard regression testing? Acceptance testing. So there's lots of different types of testing, right? What I want to talk about is what she said in the front there, which is unit testing, right? In JavaScript, we sort of have, so what is unit testing, right? What is that unit? Like, what does that even mean? In JavaScript, a unit is a function. And a function can be a bunch of different things depending on how you use it, right? What we really want to test is our functions. And those might be components, or actions, or reduces, or any other, like there's tons of different ways functions can be called. Now the questions that I asked myself when I started with testing is, why on earth should I do this, right? You write your React components, or you write your pure functions, and then you have to spend a bunch of time writing tests for those functions. Why would you ever do that? Well, the first and most obvious benefit is that you catch some bugs before they happen. Now, not how I put some there. I didn't say catch all the bugs. Unit testing catches some of the bugs, which is already very nice, right? So if you have a unit test for your component, for example, and you change something, you know, you're going to get a result like this, where it says, hey, you've messed up, like this test failed, right? There's something wrong here, something changed that you didn't want to change. So, you know, maybe fix your stuff. But that's kind of a tiny side benefit, in my opinion. I don't really test to verify that things don't have bugs, right? What I verify for is two other things, which is test or executable documentation. This is actually kind of interesting because if you think about it, so what we started doing is I'm building a new library to help with, you know, styled components. And what we want to do is we want to have tests, but actually also move those tests and the results to the documentation. So we're working on something that's going to take Jest snapshots to actual documentation, so you can verify that the examples you show in your documentation actually are exactly the code that runs. But anyhow, so tests are executable documentation, and we'll see some tests later, and you will see what I mean. But also, testing makes you write better code, right? Just generally, if you write code that's testable, it's in most cases going to be much better code than if you wrote untestable code, because untestable code is full of side effects, it's horrible to read, it's probably in some sort of callback hell, right? If you write testable code, the chances of that code being good is quite high. So let's take a look at a very simple function, right? This function takes 2 arguments and hopes they are 2 numbers. So this is something about JavaScript, right? In JavaScript, you always hope something is a number, or you always hope something is a string, because we don't have type annotations, which is another reason why we need to unit test. So here we hope that 2 numbers are passed in and then we add them, or you could also pass in 2 strings and it would add them, but it's not kind of what we want to do here. And then we want to test this function. Well, there's 2 major things we want to test. The first one is that it adds 2 numbers. Well, who would have guessed? So what we do is, and the second thing is that it doesn't add a 3rd number. Now this might seem kind of weird. Why would we test that it doesn't add a 3rd number? But really, imagine having a function and then accidentally passing in too many arguments with the spread operator. And suddenly everything breaks because your add function is adding the 3rd argument as well. We don't want this in this case, right? We want this function to just add the 2 arguments that we pass in. So we test that it does that. The first test is obviously nothing special. We just say, add 2 and 3 should equal 5. Well, who would have thought? This is obviously a very simple example, right? Bear with me here. This isn't like, you wouldn't test it like this. The syntax you see here, if you haven't seen it before, is sort of the Mocha style syntax, which I prefer. There's a bunch of different ways you can test. So here it says describe and it and expect. You can do behavior-driven tests, or there's tons of different styles. I prefer this one because I think it's really nice and readable, and it also gives you really nice output in the console, as we'll see soon. And then the second test, that it doesn't add the 3rd number, says just tests that it doesn't add the 3rd number. Now notice how down here I did expect add 235 to equal add 23. I could have also said expect add 235 to equal 5, right? Because we only want to add the first 2 arguments. But the thing is, the behavior that add 23 returns 5 is already verified in the test above. If I put 5 there and I messed my function up somehow so it suddenly multiplied, right? The second test would fail, even though it's still true, right? We still don't add the 3rd number. But what we really want to verify is that we don't add the 3rd number, right? We don't want to verify the result of add to 3. So that's why we test it this way. This is something to be aware of when you're testing things. Try to make your tests as contained as possible. This is a tiny nugget of wisdom in between. Make a test as contained as possible, right? If you change something and 15 tests break, even though only 1 should have been affected, you should think about how you're testing things. Anyhow, so we verify these 2 things, and then when you run that, it just looks like this in a console, right? Assuming we haven't messed up our add function. It just says, it adds 2 numbers and it doesn't add the 3rd number. Well, that's very fancy. Now you have some developer on your team and he's thinking, this function looks kind of nice, but it doesn't do exactly what I want it to do, I kind of want it to do this. I kind of want it to multiply things, right? If some of your developers do this, you might want to think about, kicking them out. But imagine somebody doing this, right? This would be an absolute catastrophe because everything would suddenly, all your calculation would suddenly be wrong. Thankfully, you've added unit tests, so you can fix this messed up function, because what your unit tests will say when the person submits a PR is, hey, whoa, something's very wrong here. Your add function with 2 and 3 suddenly doesn't return 5 anymore. It returns 6, okay? Something's very messed up here. And you can just go in and say, okay, well, add should obviously add to numbers, but so let's not change this function, but let's add a second one, multiply, right? And then you can fix the test and everybody's happy and you've just avoided a grave bug. Notice something else here. The numbers I chose in the tests were add 2, 3, right? I didn't choose 1 and 1. Why? Well, because if I chose 1 and 1 in the tests, this test would have still passed, right? Because multiplying 1 by, oh no, actually it wouldn't. What am I talking? 2 and, thank you, 2 and 1. 2 and 2, so that's it, 2 and 2, sorry. Because, man, my brain. See, that's what I get for. That's why I chose 2 and 3, because it'll break if you change it, right? So you need to be wary of the test cases, of the fixtures that you have, because there might be edge cases you're overlooking. That's another tiny nugget of, I should put those tiny nuggets of wisdom in the slides actually, now that I think about it, next time. So now we have a function and we fixed it. Now that's very nice and all, but how often do you really write a function that adds some numbers, right? That's a pretty trivial example. So let's take a look at something you might actually do very often, which is testing Redux actions and Redux reducers and that sort of thing, right? How do we test? Like Redux is kind of like the meat of your application, right? It does all of the state handling. React just goes and renders your app, right, based on the current state shape. But you want to really verify that the actions that happen really change the state in the way that you anticipate. Now imagine a navbar component, right? It's in its own folder. We've got the navbar.react.js file, which is just the component. And then we've got some actions, some constants, a reducer. And then we have some tests for the actions and for the reducer. It's pretty, nothing fancy going on here. It's just a navbar component. Let's take a look at our one action that we have, which is the toggle nav action. In the user interface, you can imagine this sort of like opening and closing the navigation on mobile, right? It's a pretty standard action you might have. How would we test this? Well, actually it's kind of easy, right? We just import it and then we just verify it returns an object that has a type of toggle nav, right? That's it. This isn't I don't normally test Redux actions because they're pure functions in the optimal case, right? If you're using Redux Thunk, for example, that's very different because with Redux Thunk, what you have is functions that are very, very hard to test because you have to mock a lot of things, you have to inject things. It's not very nice. If you just have pure functions and use Redux Saga, that's not a topic I'm going to get into, but use Redux Saga, you're going to only have pure functions as your actions, which is really nice to test. I don't actually test those because, this doesn't help me solve any bugs. That being said, we just do this. Our function returns an object with a type of toggle nav, so we just verify that calling that function returns a type of toggle nav, and that's it. Nothing fancy going on here. This is what it looks like in the console. Obviously, it returns the right type. That's not very interesting. Let's take a look at the reducer, because that's a bit more interesting. We have a pretty simple reducer with a simple case, right? We just have an open property. And then if the toggle nav action is called, we just switch the open property to whatever it was, to whatever it isn't, right? The important part here is that we do object.assign, so we don't mutate any object. That's really important in your Redux reducers. Don't mutate anything, because that might introduce really, really ugly bugs that are really hard to fix. Always, always, always try to be immutable in your Redux reducers. In fact, I'd recommend using something like Redux immutable middleware, which forces you to be immutable, which is a very good thing. So how do we test this? Well, there's two cases that we want to verify. The first one is that it returns the initial state, and the second one is that it handles the toggle nav action, right? So for the first one, we just expect calling the navbar reducer, with an undefined previous state and an empty action to just equal open false, because we want the nav to be open, to not be open. Now, something you might notice here is that this is not a perfect test. Why? Because the initial state is defined in a variable in our navbar file, right? We don't want to verify that our initial state looks like this. What we want to verify is that our reducer returns the initial state, whatever it may be. But in this case, because we're not exporting the initial state, we have to do it like this. So every time you change the initial state, this test will break, even though the test is still working. The test isn't broken. You've just changed the initial state, right? So that's something to be aware of. This isn't an optimal case test. I wanted to put this on there because it's kind of always nice to be aware of. So what you would do in this case, or what I would do in this case, is just export the initial state, import it here, and expect calling the reducer with an empty thing to equal the initial state. The second thing we want to verify is that it handles the toggle nav action. So in this case, we just call the navbar reducer again with an undefined state, but this time we call the toggle nav action as the action. And then we expect the state that comes out of it to equal open true. You might guess what this looks like in the console, right? Nothing fancy. It just says, the navbar reducer returns the initial state, and it handles the toggle nav action. We've seen this a bunch of times now. Now, the title of this talk was Testing React Applications with Jest. Why Jest? Why not Mocha or Tap or anything else, right? Why would you use Jest as your test framework? There's three reasons for it. The first is performance. Jest is freaking fast. We used Mocha previously in React boilerplate, and we switched it over to Jest, and our tests got 2.5 times faster, I think, just by changing the test command, right? It's pretty ridiculous. Now, some of you might have, who in here tried Jest like a year ago? And who in here thought it was horrible? Yeah, most people. So the thing is, the Jest that you know from a year ago is entirely different from the Jest that is today. They've now put a full-time employee in it. Literally, the only thing that's the same for the Jest that from a year ago and for the Jest today is the name. That's literally the only thing that's the same, all right? So if you tried Jest a while ago and you were like, oh my god, this is horrible, try it now, because it's actually really, really, really good. So now it's like really fast. Also, we have this thing called snapshot testing, which I'll get into very soon. That's very, very nice to test everything from actions to components with. And then the third reason is that it has constant improvements. Facebook has now 2 full-time employees on it, and they're creating a team in London, and it'll soon be like 5 or 6 employees just working on Jest and Yarn, which is pretty great, because that means, contrary to things like Mocha, where a single person is building it, this will actually only get better, and it's already really good now, right? So that's why I would bet on something like Jest. Let's talk about the meat of React apps. How do we test our components? And this is where snapshot testing comes in. We have this really simple component, right? It's a button component. It returns a button tag, it has a class name, it attaches an on-click handler from the props, and it renders its children, right? Nothing very fancy, a tiny component. How does Jest snapshot testing help us here, and why is it different from other unit testing methods of components? So there's 3 major things we want to verify about our button component, right? First, that it renders a button with a class name. The second is that it attaches the passed-in on-click handler, and the third is that it renders its children, right? Those are the 3 things that are, important about this. Literally the 3 things that our component does. Now, with Enzyme or Mocha or whatever, you'd sort of render your component, and then you try to verify, in my rendered component, first tag is a button. That tag has a class name. So I'll show you what this looks like with snapshot testing. This is what a snapshot test looks like. This is what verifies that we render a button tag with a class name. Now you might notice there isn't any logic here. We don't say anywhere this should be a button tag, and we don't say anywhere this should have a class name, right? We don't say any of this. We just say render the button and then match a snapshot. What Jest does is, so I should probably say this renderer.create to JSON thing is the React test renderer that they also released when they released Jest snapshots, which is kind of like Enzyme shallow rendering, except it renders to JSON. There's now an extension for Enzyme, so you can, using Enzyme and Jest is a really good idea. They both work together. It's not like exclusive. I use the React test renderer here because I didn't need any fancy DOM interactions. So anyhow, so the thing is, we render our component and we render it to JSON, and then we expect the JSON tree, to match the snapshot. And the first time this test runs, what Jest does is it goes in and it says, okay, you've just rendered your component to JSON, we'll just put that in a file, and your test will pass. And then the next time your test runs, Jest will take that, and it will say, okay, let's render the component again to JSON. Okay, does that JSON look the same as the previous JSON? And if it doesn't, it will say, hey, you've changed something in your code, and it's changed something in your rendered HTML, right? It'll say, hey, the class name's different, or hey, you're now rendering an A tag, or something, And then you can go and say, hey, okay, that's exactly the change that I want. Yeah, put that into the snapshot. And if you don't want it, you can say, okay, no, leave the snapshot as is. Let me try and fix this, right? And this way, you avoid all of the manual testing, because all you do is just render a snapshot and then compare the 2 snapshots against each other, right? There's no more wonky find button.length equals 1, that sort of wonky. No, you just match snapshots and that's it. What does that snapshot look like? Well, it just looks like the HTML that's rendered into the DOM, right? So Jest creates this file, this snapshot file, which is just a JS file that exports a bunch of stuff. You should check this into Git. It's in an _snapshot__ folder. And then every time you make a change in the code review, you can see, okay, this was the code change, right? These lines of code have changed. This is what the business logic that has changed. How has this affected the actual output of the component? Well, right? And then you can think about, okay, is this what I want, or is this not what I want? When I first tried snapshot testing, I was like, holy cow, this is horrible. Because for every single tiny change you make in your components, you have to, you get an error saying, hey, dude, that snapshot doesn't match. But in reality, it's a very, very nice way of working. Combined with the Jest watch mode, I just make changes in my components, right? And Jest tells me, okay, this has changed. But it doesn't throw an error or anything. It just says, this has changed. Is this the way you want it? And if it is the way you want it, you can say, okay, just save that snapshot for the next time. If it isn't the way you want it, you just fix your component, and then Jest will say, okay, now it looks exactly how you want it or not. And it's such a nice way of working because you avoid all of the manual trying to find things in the DOM while also making yourself develop much faster because the snapshotting is just instant. Not instant, but really, really, really fast. Let's take a look at a different example with a prop passed-in. We want to verify that our button attaches the onClick handler. Well, what we do is we render a button with an onClick handler. Very fancy stuff, I know. The only part that has changed from the previous test is this onClick thing that we pass in here, and then we take a look at the snapshot, and the only part that has changed here is that it now says onClick is a function. And this way, if somebody breaks our properties, or if somebody changes the property that the onClick handler is passed into, we'll immediately know. And then the third thing is just it should render its children because we do want to verify that it does that. Again, the only thing that's changed is we pass in some children, and then in our snapshot, well, who would have thought the only thing that's changed is, it has some text. This is really, really, really quick. I've never tested my components quicker, right? This is the quickest testing ever that I've tested my components in. This is, again, just snapshotting is very, very nice, right? But it's not exclusive with Enzyme. So I still use Enzyme for DOM interactions, right? I still use Enzyme sometimes for clicking on things in my rendered components, and you can always render those to JSON and then just snapshot it, right? But the thing is, with just snapshots, I'm so much faster because I don't have to worry about manually verifying every single change that I do. I just change it, and that's it. All right, now since I have a bit of time, I want to do some actual testing. I've very recently switched to using an American keyboard, which I haven't done before. And I've also very recently switched to Vim. I'm horrible at Vim, so I'm not going to use it. Seriously, I'm freaking slow. Is this readable for the people in the back? Or is it too small? That works? Okay, that's good. So what we want to test is we have this to-do list. I should probably show what the application looks like. I built this tiny application with Create React App. When it loads, you'll see that it actually doesn't do very much. It renders a to-do list. And it's a bit off-center. Why is it off-center? Oh, that's why. Yeah, there we go. It doesn't actually do much. You can click on to-dos and cross them out. And then you can add new to-dos. I'm sure you've all seen a to-do list before. So I've tried computer. Have I given? Yeah, kind of. I've got an ESLint warning. Oh, it doesn't matter. So what we really care about here is our to-do list component, right? It doesn't do much. It has some items in its state and the input value. On component we'll mount, we just set the items that we get passed in from properties, or we set an empty array. We can set the input value. You can add items, so just a simple transform. And then we can check items, which just checks the item. And then we render a bunch of stuff. They make this a tiny bit smaller, so it's a bit more. No, it doesn't work. Doesn't matter. We just render all the items with this item component. The item component is just a simple list item. If you haven't seen this weird thing before, that is styled components. Definitely check it out. I'm totally not plugging my own things here. No, it's pretty great actually. So as we can see, this list item will, if it's checked, it will add. It will be strike through, which you've seen. But that's not the part we care about here. On click, we just say, check the item, and it renders some text. And then down there, we have a tiny form and an input. And I want to test this component, right? So there's 4 things that we really care about. The first one is that if we render it just empty, it should match its empty snapshot. The second thing that we want to verify is that it should match its snapshot even when you pass in items. Then that it can check an item, and then that it can add an item, right? Those are the 4 things we really care about in this component. So let's first, do the whole empty snapshot thing. Now, I am doing live coding. This isn't recorded or anything. I'm actually typing. If I make any mistake, just scream at me, okay? Just go, you idiot, what are you doing? So what we'll do here is we go const3 equals renderer.create, and then we'll just render our component, right? So we go to-do list, and since we don't care about any items, we just do this. And then, what we do is we just go expect something we've seen before, right, with the button. We expect the tree.toMatch snapshot. Thank you. See, that's why I should always code in front of an audience, right? I won't make any mistakes ever again. And we just do this. Thank you. That was a good catch. Now let's actually run Jest. I don't care about you anymore. npm test. This will run Jest. And as you can see, it's now said one snapshot written in one test suite, right? All the tests pass because obviously there's no test yet. And we've just written a snapshot to a file. What does that actually look like? Well, this is __ snapshots. I don't know why this text is so small. So this is an __ snapshots folder. And in there we have a snapshots file, which I'll highlight as JavaScript. Doesn't look, we have the string. This is what our component has rendered to the DOM, right? Nothing fancy going on here. We don't see any items. We don't see anything. Now, if we went into our component and said, hey, actually, I want to, what if we just remove this input, right? Well, what you can see in here is that immediately just goes, whoa, wait, the snapshot just changed. Are you sure you want to do that? Are you sure you want to just, get rid of that? And it says one snapshot test failed in one test suite. And now, if I want this change, I can just press U. And if I press U, the snapshot in the file will be updated. So let's do that just for fun. This is obviously not the correct behavior. Now our snapshot has changed, right? It doesn't have the input anymore. But actually, I kind of want that. So, let's put it back in. Now it will say again, you've changed something. Oh, I'll just update it. And that's it. That's kind of the workflow that I have when working with these snapshot tests, which is really, really nice. Let's test something a bit more interesting, right? We'll just copy this part because I don't want to type it again because I'm definitely going to mess it up again. We pass in some items. So let's create an array of items. So this is where the American keyboard comes in because I still have the German keyboard visible, but it's like whenever I type, it's the American keyboard. So if I mistype, right, it's just me messing up with the American keyboard. Every item has some text, I think. Hello world, and it is checked or not. This one shouldn't be, or actually, let's make this checked. Then let's add a second item that's not checked. Oops. Fuck. How do I do it back? How do I do it? See, this is where, there we go. I'm checked. Man, that was hard. So the thing is, normally when I don't know where a character is, right, I just look at the keyboard and go, oh yeah, where is it? But that doesn't work because it doesn't map. So it kind of messes me up. And we pass in some items in here. We just go items. And then we just do the exact same thing, right? We expect it to match the snapshot. Now the first time, Jest will again tell us, a snapshot was written in one test suite. Wait, let me make this bigger. There we go. The snapshot was written in one test suite. We can take a look at our snap file. It's again not highlighted. I don't know why. It has this item in here where it says hello world and checked is true. And down here it has another item which says checked false. These weird class names right here, that's styled components doing its thing. So the nice thing about this is actually, I only very recently discovered this, that if you use styled components, the class name is based on the hash of the contents of the string, right? So every checked list item will have the same class name and every non-checked list item will have the same class name. But the thing is, when you change your styles, obviously the hash of the contents change, right? So this class name changes. That means you get an immediate notification, whoa, something changed here. Are you sure you want this? Which is really nice. Anyhow, sorry. I keep going on about styled components. Maybe it's good. Maybe you should try it, Think about it. Think about that when you go back home. No, I'm just kidding. So we've got another snapshot that verifies everything works. Let's trigger another test run just for fun. Everything passes because we haven't changed anything. So now the nice thing is if we change something here, like if we removed the checked part, it would say, oh, wait, this isn't checked anymore. Like, what are you doing? Why would you ever do this? In here, it actually changes the class name as well because the class name is, based on the hash of the contents of the string. So, now it has the class name of a non-checked item. And we realize, actually, no, we kind of want to set check to true, to check to whatever. And we know it passes again. Who would have thought that? Genius. Now it gets more interesting, though, because now we want to check an item. Ooh, this is where it gets really fancy. So now we need to do a bit more work. We can still copy this part, and we can still kind of copy this part. But instead of immediately to JSONing, we want the component here. So we say const component equals render.create, and down here we say const tree equals component dot to JSON. Actually, we don't want that to be a const. You'll see why soon. And we'll just say render the initial state here, just so people can actually read what we write in here. And then we go and find the first item. This is probably the hardest part of this whole test. And this is why I kind of like having enzyme, because it makes these sort of things much easier. But I won't use enzyme now because I want to show you how Jest works. So we can go const item equals, and we want to have, we have the tree now, so we can go tree.children, which is the children node that we render inside our components, and then we go filter. And then we have a single child, right? Oops. God damn it. And we want that child.type to equal li, because we want to have the first child, right? And then because filter always returns an array, and we only want to have one item, we just say, okay, just give us the first item, right? We don't care about all the others, just give us the first item and we'll check that. And then we just go, check this item. And we do this, if we take a look at our code, we do this by calling the onClick handler. So we just go item.props.onClick, manually call it. Now the problem is, if you did expect tree to match to match snapshot down here, it would still be the original snapshot, right? We have to re-render our component, and we do this by simply doing this again, right? And then we just snapshot that state. Snapshot, state with checked item. And I'm pretty sure I've messed up somewhere here. So let's see if Jest complains. Ah, goddammit, thank you. See, I need an audience for every single line of code I write. Seriously, imagine just having 50 people watch you code and being like, no, you're doing a mistake there. Actually, that might be horrible, now that I think about it. Well, we'll see. So obviously the test passes because it just wrote the snapshot, but let's take a look at the snapshot, right? In the initial state, the first item is checked, the second item isn't checked, and then we have the form, normal stuff. Then in the second one, the first item isn't checked anymore, so our test verifies the right thing, right? And then down here, we have the same thing. Now, if we broke our check item function, right? If we said, actually, let's change this right here, Jest would immediately say, hey, whoa, it doesn't check an item anymore, right? Items just stay the way they are. And you'd immediately know if you want that change or not. And we obviously don't want that change, so we'll fix that again. So we've verified this function kind of, and then let's verify the last thing, which is that we want to be able to add an item. We'll again do the same thing as up here. We'll save the initial state, pass in some items, blah, 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 yada, yada, yada. And so now what we want to do is, in our form, we want to set the input value, because this has an onChange handler, which sets the input value to something in the state. And then when we add an item, we just use that value as the text, right? So we want to put some stuff into our input, and then we want to submit the form, right? So we want to call this function. Again, this is a bit more painful than it would be with Enzyme, and this is where Enzyme is really useful, because now we're trying to find things inside our components, and Enzyme has a nice API for that. But for all the other stuff, Jest is perfect. So now we're going to try to find the form and the input. So we say, const form equals blah, 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 component dot filter. Component.children dot filter. Tree. See, this is where talking about it helps me, because I immediately hear my mistakes. So we say tree.children dot filter, which is hopefully what we did up here as well. Yeah. Then we get a single child, and god damn it. And we go child.type equals form. And then again, we have to take the first item because filter returns an array. And then to get the input, we just say form.children. Form.children. Form doesn't like me. Child, and we just check that the child.type is an input. We could just take the first, because there is only one child in the form, but we don't want this test to break if we add more. So, let's do it this way. We say input, and again, we have to take the first item. And now that we have the form and the input, we can set the input value by just saying input.props.onChange, I think it is. Is it? Input, yeah, onChange. And we call that with some value, it doesn't actually matter. Some text for the item. And then what we do is we say form.props.onSubmit. And now an item should be added to our component. And then we just try to do the same thing again. This time I'm not going to copy the let, hopefully. There we go. And we want to snapshot that again. Oops. Let's hope that worked. Okay, there's no error, is there? God damn it. Okay, something messed up. I know what. So onChange is an event handler, right? And this calls set input value. So what set input value do is it reacts to an event, and it takes event.target.value. We just passed in a value. That was my mistake, right? So what we should do is we create a new object, and then we say target. We just kind of mock the event. It's not mocking, but we fake it. We say value, and then blah 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 blah. There we go. Now we hopefully don't have an error. God damn it. Can every property prevent default of undefined? Well, that's a problem. Why? Well, because the onSubmit thing, where is it? Actually, the add item thing. Oh, whoa. How did it work the first time around? Why did that work? Like this calls event.prevent default, but we didn't pass in. Okay. Where do we actually call it? Oh yeah, no, sorry, that actually makes sense. So down here in the onSubmit, we need to do this, prevent default. So this is where, enzyme is really helpful. If you didn't know that enzyme was very helpful, which you should by now. Yes, no errors, that's good. Let's write another time, yeah, no errors. Let's take a look at the snapshots to verify that they look the way we want them to. That's the one thing that's a bit annoying with snapshots is they're not in any order. So, I mean, they are in a certain order that every test sort of is after each other with the 1 and the 2. But then we don't, like, they aren't in any order of the tests. Which test are we looking at? Man. Should add an item, there we go. I should talk less because I lose my train of thought. So what we have here is we have 2 items in the first case, right? And then the form. But then in the second case, we actually have 3 items, and it has the text that we wanted to. Yes, success! So now we've actually kind of successfully verified that our component works the way we want it to, right? Without writing much ugly code, okay? Let's leave it at that. These tests are actually kind of nice. Now, if we broke anything, right? Even something as simple as just adding an H2, right? Let's say we add an H2 and say, hey, this is a to-do list. Now, Jest will complain here, right? Jest will go, hey, whoa, this doesn't match the snapshot, right? That's kind of weird, right? That wasn't here before. But the thing is, this isn't like a test failure. This isn't something you would push up to your CI. What you do now is you look at it and you go, do I want this change? Well, actually, let me look at it, in the browser. Let's npm start this and see what it looks like. And then, we can take a look at if it is the way we want it to. This should hopefully open the browser. No, it's just the ESLint warns me again. Sorry, ESLint. Oh, yeah, there we go. So now it says to-do list down here. But we already have the to-do. Doesn't matter. We want this change because I want to demonstrate this. So now we can just press U. That was 1 click, and suddenly everything passed because we updated the snapshots. But actually, we kind of don't want that here, so we'll delete it again. Now Jest will complain again, and we just press U. It's done. That's it. So this is kind of a really nice way of working. There's one more thing with Jest that's pretty great. Jest has built-in test coverage. Test coverage is a bit finicky. Test coverage, for those of you who don't know, is essentially it puts a function after every single expression you have in your code. And it checks which part of your code you actually run in your tests and which one you don't, right? So you can go in and say, okay, I see visually, and let's just take a look, So the thing is with Jest, it has coverage baked in, which is kind of nice. So we go npm test coverage, which is all we need to do. And then it outputs this coverage folder. So the tests still run, and there we go. We see immediately how much of our function is covered by our tests, right? Have we actually covered all the branches of our component? Have we covered every single piece of logic that we have in there? And the interesting thing is it also outputs this coverage HTML file, which you can open in your browser, and which actually kind of looks nice. So as you can see here, we have this list of all the files that we have in that component. Normally you'd have all of them, of the entire app, but there isn't anything more in this app, so that's it. And now let's take a look at the input. It tells us, hey, you've run this part 4 times, you've run that part 4 times, you've run that part 1 time. It tells us how often it's run it. Very interesting stuff. Now, what would happen, for example, if we removed should check an item, right? What if we just remove this part? Now, apart from the tests breaking, right? The tests will obviously break now because there's, actually, no, they won't break. But now we immediately see, hey, your coverage is down. And if we refresh this, what you see is, hey. It visually tells you, whoa, that part hasn't been tested. Like, we haven't seen this part run at all during any of your tests. Test that part, right? And so you get this visual indication of, hey, I've missed that part of logic, right? I've missed testing this specific branch of my logic. And you can go in and write your tests for that specific branch of logic, which we've already done. And that's really, really, really nice. Yeah, and that's essentially everything I have today. I've talked about coverage. Thank you very much for having me. If you've got any questions, just ask me. I hear there is a microphone to be passed around during the Q&A. So think about your questions while somebody finds it. I don't have it. Any questions? Sorry, just raise your hand.
Test.
There you go.
Test, test.
When you were testing the on-click function in the slides, can you go to that?
Yes, of course. In the slides or in the...
In the slides, yeah.
No, one more. This one?
You're not actually testing if it's the function that you gave it to, just that it has a function, right?
Yes. Okay. That's a limitation because in JavaScript you cannot stringify functions. I think in general stringifying functions is hard. So what Jest does is it actually serializes your entire JSON tree and then it represents it in your snapshots as JSX, but what it gets is the JSON, right? So you need to create a JSON representation of whatever you pass in. The problem with functions is that you cannot you can call toString on them, but it will have very, very inconsistent results. So instead of putting the whole body of the function in there, they just say, okay, it's a function. That's it.
But what if somebody just puts a random function in the on-click in the component here? The test would still pass?
No, because you'd have a separate test for testing, as I did for the to-do list, right? In here, we actually click the item and expect something to happen, right? So this is an internal function of the to-do list, right? The on-click function calls something inside the to-do list. But if this was a function that we passed in from the outside, if item.props.onClick was passed in from the outside, you would have a spy or something that says, okay, hey, I've been called once.
Okay, thanks.
Why in this test of yours do you expect the tree to match the snapshot twice?
So, because we changed something down here in our component. So what we do here is we render the component with some sort of state, right? We render it once. And then we say, okay, give me a JSON representation of the current renderer. And then we expect that JSON representation of our component, which looks, it is an object with children and type and that sort of thing, to match a snapshot. The problem is if we only did it up here and then changed it once down here, right? Like this changes what the component renders, right? Because because here we check an item. So what we need to do is after we've checked the item, we need to verify that the changes have worked the way we wanted them to. You wouldn't necessarily need this. You kind of don't 100% need this up here because, it just verifies that the component renders. And this totally works. Like you don't have to render to a tree. So if we do this, this still works. I kind of like doing it because I get a visual representation of the initial state and the after state. So if I make a change in my components, I see, okay, the initial state hasn't changed, but the state after I've checked an item has changed, right? And so I can more easily pinpoint where the problem is or what I've changed, right? Which is why I do it. But you don't need to do this. You can just skip this part. Does that answer the question?
Yes.
Perfect. Any other questions? One over there.
Sorry. Thank you for the talk. How do you use it in TDD, and is it reasonable for using in TDD?
In what sense? Which part of it?
Jest.
Why? How is it different from other test frameworks?
You write test first and then implementation.
No, yeah. I know what test-driven development is. I know what test-driven development is. But Jest is just a test framework, right? You can do test-driven development with Jest just as much as you can with Mocha or any other of the test frameworks, right?
But it would mean that you would need to do this write snapshot manually. So
sorry, you mean with the snapshot specifically? Yes. So what's nice about the snapshots is that if you have a component that isn't built yet, you just return a div, right, or something. It's just a function. So then what you do is you just try that to match the snapshot. And then while you're building your component, you don't even have to look at the DOM. You just immediately see if it returns the HTML you run, right? So even during TDD, this isn't any problem or anything because you just get a visual representation. Okay, this is the actual HTML that will get rendered to the DOM based on your changes. And then you can say, okay, this is kind of what I want, update it. Or this is not what I want, discard it, right? So that sort of, does that answer the question? So it still works with TDD just like any other, TDD does. It's a bit different because it doesn't fail, I guess. So if you... See, this is where you realize that I don't do TDD. That's a good question. I wonder if you can mock the snapshots. I wonder if you can write a snapshot file manually and then just tell Jest, you probably can, but it'd probably be a pain. That's a good question. I'll have to research that. If you let me know your Twitter name after, I'll get back to you because I don't know actually. That's a good question. Good question. I like that.
How much of that is applicable to React Native?
Jest has a, sorry, I should have probably mentioned this. Jest has a package that is called Jest React Native. So you can npm install Jest React Native and it'll just work like Jest, specifically for React Native. It's not 100% stable yet. I know Facebook are using it for internally, but it's not 100% stable yet, which is why they don't advertise it heavily yet. But it's just the exact same API, right? It's the exact same thing, except it renders React Native components.
Thank you.
No worries.
Hi, can you briefly go through the differences between Jest and Enzyme and say what you'd use each for?
So Enzyme is like, so Enzyme gives you the renderer, so you wouldn't need to use the React test renderer, right? Because you just use shallow or something, right? You just go shallow. The problem is that Enzyme doesn't do a JSON representation, right? And you cannot go render component to JSON in Enzyme because it doesn't do that. There's a package called Enzyme to JSON, I think, which adds that functionality to JSON, to JSON. It adds the Enzyme functionality to JSON. No, it adds the JSON functionality to Enzyme, obviously. And the other thing is that by rendering components shallowly with Enzyme, you get a much nicer traversal API, right? What Enzyme really gives you isn't any part of this, right? You'd still use this, but you just go render to shallow and then just go, you know, whatever the API for Enzyme to JSON is. But then you could also go in your components, instead of having to do this, instead of, wrong test actually, let's do it down here. Instead of having to do this ugly thing where you're filtering over children, you can just go in and with Enzyme say, hey, actually my item is my component dot find li, I guess it's 0. I can't remember the exact API, right? So it gives you the tree traversal API. You don't have to do any of this, which is really nice. Like I use them in conjunction. I don't use only Jest. I use Enzyme for like more complex tests like these, where I have to actually interact with the DOM to test something. Does that explain it?
So Enzyme is just better at DOM interaction.
Yes, exactly. It's a replacement for the renderer that gives you a nice API to find things in the components and do things, right? Whereas Jest is like the actual, hey, I expect this to be this and that sort of thing.
Hey, it's not really a Jest-related question, but how far
Sure.
would you go with the testing? Would you even hook up with Redux? Because you mentioned in the beginning with the unit test, do you really consider testing actions a good practice? Or what if I take my view and just test it with the whole Redux flow, so I don't need to test the actions?
So the nice thing is that, and this is something that Jest doesn't heavily yet. That's a good question. Jest doesn't advertise it heavily yet. But essentially, what this two-match snapshot thing does is it just saves some JSON blob and compares it against the next JSON blob. So this is actually perfect for testing Redux actions, right? Because I don't actually care what specifically my Redux action returns. I just want to verify it returns the same thing as before, right? That's the only thing I care about, right? So I could just go, if I had a Redux action, right? I could just go, it should match its snapshot. And all I'd have to do is just render it to with the what am I talking about? Snapshotting it with Jest. So I would go, const result equals calling my action just as a function, and then going expect result dot to match snapshot, and that's it. And that way I've just tested my action. And you could probably refactor that into an external helper and just have that run for every single action you have, verifying that the changes you make in your actions really only, affect that one action and do the right thing, which is really nice. I do test reducers because they contain a lot of the. So since React sort of, the thing about React and Redux is that React doesn't care about. So React, where do I start with this? React is a framework for specifying what your DOM looks like at a certain point in time. Right? Based on the data that comes in, this is what my DOM should look like. Based on this data that comes in, my DOM should look like a bit differently. Now with Redux, what you get is this sort of nice way of thinking about your application, plus you get this externalized stateful. It's kind of like a cycle, right? Something changes down here, we go to the store, we update it, we re-render it at the top, our components re-renders, we go back and something changes, an action, right? It's this cycle of things that happens. And I don't remember where I was going with this now, but
My question was, if you were to really get the whole connected component and test it with Jest, would you consider doing that? So, I mean, actually, how do you make sure that the connected component is working properly with Redux? I mean, you can test Redux, then it works, you test the component works, but how do I know the map state to props is correct?
So what I do is I use selectors. So reselect is sort of a library for doing that, but you don't actually need reselect to do selectors. If you have a state tree, right? So you go in a reducer, you go initial state equals something, right? I'm too. God damn it. Okay, and we just say open false, right? Our navbar state from previous, right? This is the state that this reducer will handle. I forgot my train of thought again. Where was I? Sorry.
You mentioned that you were trying to test selectors, but okay,
yeah.
You can test selectors, but how do you test that the map dispatch to props is correct? And my
So
didn't.
your map state to props would just be a selector. So that's where I was going, right? So you'd have a selector, right? So you'd have an open selector, which is just a function that gets the state, and returns back state.open, right? Nothing fancy going on here, right? It's literally just a function. But then in your map state to props, in your connected component, so if you say connect, then you can go open selector. Now this won't work as is because, but sort of treat this as pseudocode, and then you pass in your component. And this way, you test this part, and then this part will just work, because I don't need to test that connect does the map state to props thing, right? I don't need to verify that, because they have a lot of tests for that, right? I don't need to verify that. So all I need to verify is that my selectors work and that my reducers work the way I want them to, and then that's it.
And what do you do with map dispatch to props?
I don't test that. Actually, it's kind of funny because React Boilerplate has the example app of React Boilerplate, which is tiny, has 99% test coverage, and then one part that isn't tested is the map dispatch to props function. Seriously, I'm not even kidding. I haven't found a good way of testing that yet, but maybe if somebody has an idea, please come to me afterwards, because I do kind of want to test that.
Can I ask a second question? I mean, I think you answered it before already. I was just wondering if you ever considered using it with a backend, because you mentioned you can just do whatever JSON you want. I could test my REST APIs with that, could I?
Yeah, you totally could. I'm not a backend developer, so I don't. But it sounds very useful, because you could just call your API and expect some JSON blob to come back.
So you briefly showed us the test coverage, which was basically Istanbul, right? Is that an integration with Jest, or is that to do with the Create React app? Just to clarify.
No, that's an integration with Jest. So whatever Jest you have, you can literally just, that's nothing, sorry, I should have specified that, good point. You can literally just run this, and it'll work the exact same way. I hope. Yeah, there we go, it doesn't. Oh yeah, because there's some setup you need to do, but yeah, so Jest, so coverage is built into Jest.
Okay, so did the Jest team that, I think Christopher, right, at Facebook, did he build on top of Istanbul, or is it just a straight up Istanbul integration?
I don't actually know, I'm sorry.
Okay, cool.
I wish
Thank you anyway.
Actually, thank you for the reminder. I should mention that Jest is very active in development, and if you're looking to contribute to some big open source projects, they're actively looking for, like, they need help. They have huge ideas, right? So if you're looking for an open source project to contribute to, go to Jest, github.com/Facebook/Jest. There's one. Don't worry.
Thanks for the talk. I have actually two questions, and one of them about aftermocking, because it's one of the main things in Jest, I think, since the beginning, like snapshots, since now. And what are your thoughts about it? Do you use it by default, or you turn it for every file?
So actually, with the big rewrite of Jest, so if you tried Jest a year ago, they would auto-mock every single dependency you had, right? This is now turned off. You can still enable it. I've never enabled it. I've never had a need to, right? It's still built in, but it's not enabled by default anymore, which is really useful, because I don't actually know anybody who really loves that feature. So, you can still enable it. You can still somehow go jest.mockall or something, I think. I can't remember the exact API, but and then it'll still mock everything.
Yeah, but I think it was like the biggest for Jest. It was like the main feature, because it was made by default. You don't need Spice or something like that, like for mock and so
on. You can still turn that on, right? But it's just enabled by it's just disabled by default.
Yeah, but you don't use it.
I've never used it. No, I've never had it.
Okay, and the second, my question about, as you said, Jest is developing very actively, like 2 people working full time on it. And since for, I don't know, 3 or 4 months, they changed 4 or 5 versions. They changed a lot, introduced Snapshot, and so on. So how you update Jest and test, or you just stick with some version and so on?
So the thing with major versions is that they follow some semantic versioning, right? So their major versions just mean there's a tiny breaking change somewhere, right? Since I've started using Jest 15, which was the big release with snapshots, and they just today, actually 2 hours ago, released Jest 17, right? I was using Jest 16, I was like, oh my god, is everything going to break? But nothing broke, right? So the breaking changes that they've introduced so far have not been very breaking, right? In the sense that I've never had any problems upgrading.
Yeah, but for example, since Jest 12, I don't know, or 13, they changed a lot, they duplicated a lot.
Yeah. Yeah, exactly. So since what he said was since Jest 12 they changed it a lot, and that's because they had the big release of Jest 15. And as far as I'm aware, now they're just going to make tiny breaking changes because they're mostly going to introduce new features like snapshot testing, but there won't be any big API changes anymore. I'm pretty sure. Now I'm not a Facebook employee or anything. This is what rumor, but that's what I've heard. One last question maybe, so we don't get I'll be around.
Okay. So when you use enzyme, as you showed, you use shallow, so you go only one level deeper in the component tree. So if you have one component that is rendering another component, you then go deeper to that one. But Jest, as I understand, it goes as deep as the root component itself. So if you're talking about HTML, it's actually going to go as deep as the div or the input or whatever. How would you recommend when you're testing HTML so we don't get tempted as just testing the biggest, highest component ever, like the rooter component, and just test everything in one test?
That's a good question, actually. I haven't thought of doing that. That might actually be something that's useful. I don't know if it would be too much, though, because you essentially snapshot the entire DOM once, and then be like, and you wouldn't catch every single state, right? Because you cannot set every single state of every single component from the most upper level component. So I use shallow rendering for most things, actually, I think. Good question. Yeah, I just use shallow rendering for most things because, so the thing is, if you have a lower level component, you kind of don't want that to affect anything further up, right? If you have a snapshot for a low level component, changing that low level component shouldn't mess up the parent component. So actually I just use shallow rendering everywhere. It's a good question why they don't do that by default. I don't know. I'll have to investigate that. Thank you.
Hello. Yeah. One last question. Sorry, from the remote guys.
Oh, yeah,
was
sure.
through the through the
hey, everybody.
live stream. So the question is, if you made the onClick function a named function instead of anonymous, would it be displayed in the snapshot, or would it still stay the function to string?
That is a good question. Let's try it. I have no idea. I literally have no idea. Let's call it something like function test. Just 16. Sorry? Okay. All right, so he just gave basically the answer. In Jest 16, this was changed. See, this is why I need an audience when I code, because I don't ever mess up. Since Jest 16, this is different because of some node version problem, as far as I understand. And before Jest 16, it actually included the name. Now it doesn't anymore. Now it's just function for everything. All right. Thanks for having me. I'll be around.
Thank you.